to our channel, The Classroom. I'm back with a mathematics chapter, that is Matrix of class 10. Now, although I have written this as the first chapter because I am starting it as the first chapter of class 10 in mathematics, it is in between 14th or 15th chapter. You will find it in the book. Okay, it's maybe not the first chapter itself. But yes, I felt starting with matrices because this is a very interesting chapter, and I know class 10 means boards, it's a very big headache. So just thought of that exam purpose and started with matrices. I think it will be very interesting, and I think one chapter with which we will start, if it is a very good one, a smooth one, I think the rest of the book will be very easy for you, right? So dealing with this particular easy chapter, let's move on. Okay, so let's start with matrix today. Now this word matrices is the plural term of matrix. Okay, so matrix is basically a rectangular form of some particular numbers which are arranged in rows and columns. Okay, it is basically of the shape. I'll show you one example of it. Suppose matrix A is shown by we always show the matrix within a third bracket. Okay, suppose it is A, B, C and D. Okay, now this A, B, C and D are these numbers. I have just written it as like alphabets. Okay, these will be numbers. So these numbers are, all the entities are known as elements. Okay, not the elements which we do in chemistry. These are known as elements. Now, these are known as the rows and these are known as the column. Okay, so these are known as the rows, this is known as the column. Now, this is basically how a matrix looks like. Now, we will come to the different type of matrix. Okay, so before coming to the different type of matrix, I must mention you with one thing, that is the order of the matrix. What is the order of the matrix? Order of the matrix is considered in the way row into, that is number of rows into number of columns. Okay, so number of rows into number of columns. So which is the number of rows here? It is 1, 2. This is the first row, this is the second row. And this is the first column, this is the second column. So here number of rows are 2 and number of columns are 2. So it is 2 cross 2. Okay, so this is the particular order of the matrix. Now for different type of matrix which we are going to follow up, that is we are going to discuss, each type of matrix have different type of orders. Okay, so particularly the formula of the order is number of rows into number of columns. Okay, I hope I am clear till this part only. This is the introductory part of the chapter matrix. Okay, next coming to the different type of matrix. So the first one that I am going to tell you is about the row matrix. Now what is a row matrix? Row matrix are the one which have a single, that is elements are there in one particular single row. Okay, suppose A, B, C, right? So it has one particular row. This is known as, that is one row. So this is known as a row matrix. Column matrix, which has one particular column. Okay, this is one column. See? So here you can write, this is a row matrix, this is a column matrix. A matrix which has only one column is known as a column matrix. A matrix which has only one row is known as a row matrix. Okay, next coming to the square matrix. What is a square matrix? Square matrix are the one which have equal number of rows and equal number of columns. that is the order R, that is the number of columns and the number of rows are equal. So square matrix 1, 2, 3, 4. This is a square matrix. There are 2 rows, right? And here there are 2 columns. So the order of the matrix is 2 cross 2, right? So whenever the number of rows and the number of columns are equal, we call those matrices square matrix. Another example, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 rows, 3 columns. So the order is 3 cross 3. That means this is also an example of square matrix. Next, I hope this is clear to you. It's a very easy and interesting chapter. I hope you will really like to do this chapter. Next, after coming to this, after this square matrix, we will come to the diagonal matrix. Okay? Now, diagonal matrix are the ones in which only the diagonal main elements are there, rest of the elements are all zeros. Okay, that is only the diagonal are non-zeros, rest of the elements are zeros, and it is a square matrix again. Okay, diagonal matrix are usually square matrix, but it's only the diagonal elements are non-zero numbers, rest of the numbers are all zero. Like for example, 3, 0, 0, 2. So this is the diagonal, right? Sometimes we write in this way also. Okay, or maybe not in this bracket, sometimes we write in this bracket. That is, we write diagonal 3, 2. That means only the diagonal places values are given, 3 and 2. The rest of the elements are 0. We can also have 3 cross 3 element, that is 0, 0, 0, 1, 0, 0, 0, 4. This is also a diagonal matrix. Here we write it as diagonal 3, 1, 4. Whenever we write diagonal 3, 1, 4, that means its diagonal places are having the values 3, 1 and 4. Rest of the elements are 0. Okay? So this is what was a diagonal matrix, which is similar to a square matrix, but its diagonals are having non-zero values, whereas the other places it is all 0. So this is what was diagonal matrix. Next, coming to rectangular matrix. Rectangular matrix is what? That means the number of column or the number of rows are not equal to each other. You know, the length and breadth are always different for a rectangle, right? So similar way, here also the number of rows and the number of columns are not equal. So it can be of the form, suppose A, B, C, D, E, F, right? What is the order of this matrix? 2 rows and 3 columns. That means 2 into 3, right? Another way, A, B, C, D, E, F. This is, there are 3 rows and 2 columns. That means 3 cross 2. Okay? This both are the examples of rectangular matrix. Okay? So these two fall under the rectangular matrix, because here the number of rows and the number of columns are not equal. I hope till here it's very clear to you, right? Next, coming to unit matrix. What is unit matrix? Unit matrix means its diagonal elements will be 1 and the rest of the elements will be all 0. Just like diagonal matrix only, but here the diagonal matrix, the diagonal places were non-zero other than 1, or it can be equal to 1. But whenever a diagonal matrix has all the diagonal, that is non-zero numbers as 1, we call that matrix as unit matrix. Okay, or identity matrix. Unit or identity matrix. Okay, what is the example? It will also be a square matrix, 0, 1, 0, 1. Okay, 1, 0, 0, 1. This is 2 cross 2. If for 3 cross 3 it is 1 0 0 0 1 0 0 0 1. So this is for 3 cross 3. Okay, so this is the unit matrix for the order 2 cross 2. This is the unit matrix for the order 3 cross 3. Okay, both we will be doing as per the questions given. I hope till here it is quite fine with you, right? Next, coming to the transpose of a matrix. What is a transpose of a matrix? A, we write transpose of a matrix. Now, we write as A equal to, suppose A is a matrix where it is written as, let me write as this 1, 2, 3, 4, 5, 6. So what is the order of this matrix? 2 rows and 3 columns. That means 2 into 3 rows into columns, right? Again, when we will be writing the A transpose, that is A transpose T, that is A at the power T, that is transpose of A matrix, the order gets exchanged. Okay, it gets reversed. So that means what will happen is this 1, 4 will come up, 2, 5 will go down, and 3, 6 will come down. Okay, just the opposite will become. This 2 will become the first 2 elements, then this 2, then this 2. Okay, so here the order comes to 3 cross 2. Have you understood the way that I did? It can happen for any matrix, square matrix, any type of matrix. Okay, for identity matrix it remains the same. There is no change in the identity matrix. Transpose of identity remains, the identity matrix remains the same. Suppose take for another example, B is equal to 2, 3, 5 and 6. This is a square matrix. See, this was a rectangular matrix that I have taken. So B transpose equal to, this 2 will become the first line, that is 2, 5, 3, 6. Here the order remains the same because the order is not going to change for a square matrix. Just the values are differing. See, 2 and 5 went up, 3 and 6 became the next 2 elements. I hope I'm clear with this part. Any doubts, please do comment so that I can answer you back. I'll go for this identity matrix. Suppose C is equal to 1, 0, 0, 1. Okay, we need to find out the C transpose. That means this 2 will become the first 2 elements, 1, 0, and this 2 elements will become the next 2 elements, 0, 1. So is it changing? No. So that is why we said that the C matrix, that is a matrix, identity matrix, will be equal to the transpose of the identity matrix. There is no change in it. Okay. Next, after this transpose matrix, we will come to the inverse matrix. Now what is inverse matrix? Inverse of the matrix will be, that is, suppose A is equal to 1, 2, 3 and 4, right? Whenever we talk about the inverse, that means it will be minus A. Okay, we take the negative of the matrix. That means if minus 1 is multiplied to each of these elements, we get minus 1, minus 2, minus 3, minus 4. The minus sign gets multiplied to each and every of the element inside the matrix. That is what is known as inverse of the matrix. Okay, so these were the type of matrix that we wanted to, we will be getting in the sums. Okay, that I wanted to discuss with you, so that while we are proceeding with the chapter with the sums, you can easily understand what type of matrix and how we solve those matrix. So these till here was the type of matrix that we were doing. I hope it's very clear to you, right? Next, after this, let us, okay, before I start this, I will tell you something, that is, sometimes we need to find a third matrix. We will come to this point in the multiplication part. Let me first start with the addition and subtraction of the matrix. How to add a matrix, 2 matrix, how to subtract 2 matrix. Okay, suppose A is equal to 2, 3, 4, 5, okay, and B is equal to 0, 1, 5, 9. Okay, so this is matrix A, this is matrix B. Now we are going to add these two matrix A plus B. So let us first write the matrix over here, 2, 3, 4, 5 plus 0, 1, 5, 9. Now order of these two matrices, as you can see, are equal, right? Now you might ask the question that if the orders were not equal, so can we add the matrix still, or is it like we cannot add? I'll come to that example also so that it becomes clear for you. Next, so how will we add these two equal ordered matrix? So 2 plus 0, that is this plus this, then 3 plus 1, this plus this one, then 4 plus 5, 5 plus 9. So we are getting 2, 4, 9 and 14. This is the matrix after addition. Okay. Now you might see that which I was talking about of two different orders, right? So before coming to that explanation, I would just show you the subtraction also from this part. 2, 3, 4, 5 minus 0, 1, 5, 9. So you are going to have same way, 2 minus 0, 3 minus 1, 4 minus 5, 5 minus 9. So you are having 2 minus 0 is 2, 3 minus 1 is 2, 4 minus 5 is minus 1, 5 minus 9 is minus 4. So this is the value of A minus 1. Next, the question is, if the matrix are of different orders, suppose this is a rectangle matrix that I am taking, 2, 3, 1, 4, 5, 6. Okay, this is a rectangular matrix of the order 2 cross 3. And B is a matrix I am taking, it is a square matrix again. Let me take 1, 2, 4, 0. This is a 2 cross 2 matrix. Now we need to find out A plus B. Let me write the values of A first. 2, 3, 5, 1, 4, 6 plus 1, 2, 4, 0. As you can see that we cannot add all the elements with it, right? Can we add 2 plus 1, 3 plus 2, then only 5? No elements are over there. 1 plus 4, 4 plus 0 and 6. No elements are present. So in that case, it is not possible to add two different ordered matrices. The ordered matrix, that is matrix order, should be same for addition and subtraction. Should be same. Otherwise, it is not possible to add or subtract any two particular different ordered matrix. I hope I am clear with this example. Your doubts have been cleared. Next, suppose a question has been given. A minus x equal to B. Find x, okay, where A equal to 0, 3, 4, 7 and B is equal to 7, 1, 3, 0. Right? So this is the equation that is given and you have to find the value of x. So x is a matrix here. Now for that you need to first just equate out this particular equation. A minus x equal to B. That means x will be equal to A minus B, right? Now put the values. A is 0, 3, 4, 7 minus 7, 1, 3, 0. Right? So you are getting, subtract this 2, you know it. It is 0 minus 7, 3 minus 1, 4 minus 3 and 7 minus 0. So you are having from here minus 7, 2, 1 and 7. Right? See? 0 minus 7 is minus 7, 3 minus 1 is 2, 4 minus 3 is 1, 7 minus 0 is 7. So this is the matrix that we have received. So X is equal to this particular matrix. Hope this sum is very clear to you, right? And see, the orders were same. That is why we were able to solve it. Okay? We are coming up with another question. A is equal to this particular 2 cross 2 matrix and AT. We have to find AT, and finally we have to find 1 by 2A minus 1 by 3A transpose. So first let us find A transpose. As you know, just the digits get like changed. Minus 3, 0 will come up and 6 comma minus 9 will come down. So this is what is AT, A transpose. Now we have to find half A. Now let me tell you that each of these half will be multiplied to all these numbers inside A. Okay, that is the elements with A. So half of minus 3, 6, 0, minus 9. We are getting minus 3 by 2, 6 by 2, 0 by 2, minus 9 by 2. So we have minus 3 by 2, 6 by 2 is 3, 0 by 2 is 0, minus 9 by 2. So this is half A. Half A transpose, sorry, this is 1 by 3, A transpose will be 1 by 3. What is A transpose? Minus 3, 0, 6 comma minus 9. So multiply with all this, minus 3 by 3, 0 by 3, 6 by 3, minus 9 by 3. So we are having minus 3 by 3 is minus 1, 0 by 3 is 0, 6 by 3 is 2, minus 9 by 3 is minus 3. So we are having this matrix with us. Okay, we have got the two different matrix after multiplying half and 1 by 3. Now what we are going to do? We are going to just subtract this two. So half A minus 1 by 3 A transpose equal to minus 3 by 2, this was 3, 0 minus 9 by 2, minus 1, 0, 2, minus 3. Now subtract minus 3 by 2 by 2. How much you are getting? Check. Minus 3 by 2 minus of minus 1. How much is it? Plus 1. Then 3 minus 0, it is 3. 0 minus 2, it is minus 2. And minus 9 by 2, minus plus 3. That means minus 9 by 2 plus 3. So the answer, I will write it here. Okay, I am putting a star mark here so that becomes visible to you. So answer will come to, or rather I can use this part to write the answer so it becomes visible to you. This is coming to plus 3 plus 2 by 2, that is coming to minus half, 3 minus 2, and this is coming to minus 6, that is minus 3 by 2. Okay, so this is your answer. So first what we have done is, A was given, we have taken out A transpose, then finding out the value of half A just by multiplying half in with its elements, again 1/3 of A transpose, multiplying 1 by 3 with all the elements of this, then subtracting the two results. We have got this particular as the answer. Okay, next, coming to the next question again. This is a question given. M is equal to 0, 1, this is a column matrix. N is also a column matrix because only single 1, 1 column is there. We have to show 3M plus 5N is equal to a column matrix is coming. Okay, so 3M means what? We have to multiply 3 over here. So it is coming to 0 into 3 is 0. Let me write here 0, 1. That means 0 into 3 is 0. 3 into 1, 3 is 3. Next is there 5n. 5n is 1, 0 multiplied by 5. That means 5 and 0. Now 3m plus 5n will be equal to 0, 3 plus 5, 0, right? So we are getting answer as 0 plus 5, we are going to get 5, 0 plus 3, we are going to get 3. Hence, proved. Right? This was a very simple one. These type of sums are very easy. It will hardly carry 2-3 marks and very scoring obviously. You can understand that. Right? I hope this part is very clear to you. Next, coming up with another example. Now, this is a particular question. Next question. I is identity matrix. Number 1, the first only one only we will do. M minus 2i is equal to 3 into 1 minus 1, 0, 4, comma, that is 1. This is again a 2 cross 2 matrix. Now, we will find out M is M minus 2 into, that is, this is 1, 0, 0, 1 matrix, right? Square identity matrix, 3 into minus 1, 0, 4, 1, right? Now, multiply this and change it to the other side. Minus 3, 0, 12, 3, plus 2, 0, 0, 2. Okay? So we are having, after adding, minus 3 plus 2, minus 1, 0 plus 0, 0, 12 plus 0, 12, 3 plus 2, 5. So this is your matrix M. Okay? So this was the answer. I hope it is very clear and it's very easy and short process. You won't have any problem. Right? Okay. Now next, coming up to multiplication. Now we are starting with the multiplication of the matrix. Now multiplication of the matrix is only possible when the number of columns of the matrix, first matrix, is equal to the number of rows of the second matrix. Number of columns of the first matrix is equal to the number of rows of the second matrix. I'll come to it, you'll be able to understand. Suppose it is 2, 3, 4, 5. Okay, this is a matrix A. I'm multiplying with matrix 2, 1, 3, 0. This is a 2 cross 2 matrix, this is a 2 cross 2 matrix. Okay? Okay. So, how will be adding this? Sorry, multiplying this? This row will get multiplied with this row first. Okay? So that means this element with this element, this element with this element, and this element with this element. Okay? That is 2 into 2 plus 3 into 3. Okay? Next, these two elements will again go with this 1 and 0. That is 2 into 1 plus 3 into 0. Okay? Next, 4 and 5 with this again. 4 into 2 plus 5 into 3. Right? Again, 4 and 5 with 1, 1, 0. 4 into 1 plus 5 into 0. Okay? Now add up. This is coming to 4 plus 9. This is coming to 2 plus 0. This coming to 8 plus 15. This coming to 4 plus 0. So you are having the answer as 13, 2, 23 and 4. Right? Okay. So this is how we multiply. You can have a look. You can easily understand. Okay, the process, because I have done it very slowly. Next. Suppose a matrix A, okay, is of the order M into P, okay, and there is multiplication between matrix B, which is of the order N into Q, okay. As I said, the column of the first matrix should be equal to the row of the second matrix, okay. In that case, let me do one thing. Let me write this as P only. It will be easy for you to understand. Okay? So, and let me write this as N. It will be easy for you to understand. Okay? The column, this is a column, right? This is row, this is column. This is row, this is column. This is a first matrix, this is a second matrix. The column of the first matrix should be equal to the row of the second matrix. Column of the first matrix, equal to row of second matrix. Okay? So, the result that we will get, AB, okay, that matrix will have the order m into n. That is row of the first matrix into or cross column of the second matrix. Row of the first matrix, column of the second matrix. M cross n. Okay? You can write it down if you want, because it is actually the formula. We will come to the sums. You can easily understand how we get it. Okay? Or how we solve it. Just note it down that the column of the first matrix should be equal to the row of the second matrix. This is the criteria. And the matrix which we get after the multiplication of two matrices is, the order is row of the first matrix cross the column of the second matrix. That is why I have written M cross N. Right? Next. Suppose I am taking a rectangular matrix 2, 3, 1, 4, 5, 6. Okay? I am multiplying with a rectangle. This is of 2 cross 3 matrix. Okay? You can see 2 columns, 2 rows and 3 columns. I am taking it for 1, 2, 5 and 6. Suppose this is a 2 cross 2 matrix I've taken. Okay? So, I said that the columns should be equal to the rows, right? There are 3 columns here, right? There are 2 rows here. 1, 2. Is it possible? No. Right? I said we need to have equal number of columns of the first matrix to the equal number of rows of the second matrix. Right? The column of the first matrix should be equal to the number of rows of the second matrix. But here there are 3 columns. Here there are only 2 rows. So, to have a multiplication, we need another row. So, let me take it as 0, 2. Okay. Now it becomes a 3 cross 2 matrix. Now in this case, multiplication is possible. Okay. So, let's multiply and see how much we are getting. Now this will be multiplied with this. So we are getting 2 into 1 plus 3 into 5 plus 1 into 0. Next one. 2 into 2 plus 3 into 6 plus 1 into 2. Okay. Next again. 4 into 1 plus 5 into 5 plus 6 into 0. Next one. 4 into 2 plus 5 into 6 plus 6 into 2. You're going to get 2 plus 15 plus 0. 2 plus 15 plus 0. Here I am getting 4 plus 25 plus 0. Here I am getting 4 plus 18 plus 2. And here I am getting 8 plus 30 plus 12. So you can add it and see how much you are getting. You are getting 17. Here you are getting 6 plus 18, that is 24. Here I am getting 29. And here I am getting 20, that is 50. Okay. So this is how we multiply two different matrices, and you can see the result that it is M cross N, that is 2 cross 2 matrix. Okay, the one which we have got is 2 cross. I said the column of the first matrix should be equal to the column of the row of the second matrix. Column of the first matrix should be equal to the row of the second matrix. That is what it is. See? So the matrix which we will get is 2 cross 2. That's what we have got. Okay, now we'll see for multiplication whether commutative law holds or not. Okay, that is AB is equal to B. Okay, now let's take for example A is equal to 1, 2, 3 and 4, and B is equal to the matrix 2, 0, 1, 2. This is a particular matrix. So let's find out for AB. This is 1, 2, 3 and 4. This is 2, 0, 1 and 2. So we know 1 into 2. It is up to you whether you can understand or not. That is, I can do it directly. 1 into 2 plus 2 into 1. Still I'll write it for you. 1 into 2 plus 2 into 1. Those who are have already practicing, please do it in that way. You can either finish it up in this or you can directly do it without making a mistake, obviously. 1 into 0 plus 2 into 2. Next, 3 into 2 plus 4 into 1. Next, 3 into 0 plus 4 into 2. So you get it as 2 plus 2, that is 4. This comes 4. 6 plus 4, 10. This comes your 8. Okay, so this is your answer. Next, BA. BA first we will write the B, 2, 0, 1, 2, and this is your 1, 2, 3 and 4. So you are having 2 ones are 2, that is, let me write it down, 2 into 1 plus 0 into 3, then again 2 into 2 plus 0 into 4, 1 into 1 plus 2 into 3, 1 into 2 plus 2 into 4. So we are having 2, 4, this is 1 plus 6, 7, and this we are getting 2 plus 8, that is 10. You can make out that AB is not equal to BA. Okay? As for example, you can also check for associative law. Associative law also sometimes holds, depends on the conditions. You can have a look at it. You can take any 3 matrix and solve for it. Okay? Just check what the answer is coming, whether they are equal or not. That is your homework. Okay. Next, coming to the next part of multiplication. Now, suppose this question has been given to you. M cross 3, 6 minus 2 minus 8 equal to minus 2, 16. So, as you can see, this is a 2 cross 2 matrix and this is a 1 cross 2 matrix, right? That is a row matrix. Now, as per we know, we have to find the matrix N. Now, what should be the order so that we get the matrix 1 cross 2? Now, we have already known to it that as per the condition is, that is column of first matrix should be equal to the row of second matrix, right? So as per, column of this is 2, right? And here also that means if I take it as A cross B, this should be, sorry, this is a second matrix. This, that means B is equal to 2, right? This is the column of the matrix M. This is the first matrix and the second matrix is 2 cross 2. So its row is 2. That means this 2, that means the value of B will be 2, right? And we know that the resultant, that is a result matrix, it should be of, that is the row of the first matrix into the column of the second matrix. That means A into 2. So if we consider A into 2, that means it is A is equal to 1, right? So that means A is equal to 1 and B here is equal to 2, right? So we get the matrix as like in the form X, Y, okay? A row matrix, and we are having 3, 6, minus 2, minus 8. Now check it what the answer is coming to. Now let's multiply and see. So this is of the form of 1 cross 2. So x into, that is 3 into x plus minus 2 into y, and that side it is coming to 6 into x plus y into minus 8. That is equal to minus 2 comma 16. Okay, so you are having here 3x minus 2y, and here you are having 6x minus 8y. Two equations you are having. I know you can solve it using the simultaneous equations. So you can solve it, I guess. So the two equations stand out to be 3x minus 2y is equal to minus 2 and 6x minus 8y equal to 16. These are the two equations, right? Now what you can do is simply you can multiply, and like this is equation 1, this is equation 2. So if you multiply this with 2, okay, let's check out, or like this is 2 here and it is 8 here, so you can multiply this with 4 and check. Okay, so I'm planning to do it somewhere else. Let's see if I can finish off here this in this space. Next I will use up this again. Okay, so this is coming to 12x minus 8y equal to minus 8, and this is coming to, this is multiplied by 1 only, 6x minus 8y equal to 16. Now as you know, we are going to subtract this, change the sign of the lower equation. This will change to minus sign, this will also change to minus sign. So here you are getting 6x, 12 minus 6, 6x, this is getting cancelled, that is equal to minus 24. Okay, so as you know, x is equal to minus 24 by 6, that is equal to minus 4. And what is the value of y? You can put it and see, that is in any of the equation. 3x minus 2y is equal to minus 2. Here you can put, that is 3 into minus 4 minus 2y is equal to, you can bring this to here, that is equal to 2y. So you are getting here minus 12 minus 2 is equal to 2y. You are getting minus 14 is equal to 2y. So y is equal to minus 7. So you got the value of x as minus 4 and y as minus 7. Now just put the value here and check whether the answer is coming or not. If it comes, that means your answer is correct. Okay, you can simply put it here and check what the answer is coming to in these places. Okay, and see whether it is coming to minus 2 and 16 or not. Like here we have got 3x minus 2y, right? So it is coming to, if it is 3x minus 2y, so we are getting 3 into x is minus 4, right? That is minus 12. And where is it? 3x minus 2y, that is minus 12, and it is minus 2y. That means it is coming to just a second. Sorry, it was minus 2. It should have been plus 2 here. That's what I'm checking. This is plus 2 minus 2y. This is plus 2. That means it's coming to 10. Y is equal to, here it will come to minus 5. So as soon as you are multiplying 5, that is minus 5 into, that is coming to 10, you are getting the answer 2. Now you can correct it. There was a small mistake here with the calculation I have done in such a small part. So please be careful whether calculations. Okay, so we are having minus 2 here. So that means the other term will be 16. You can simply put the value of x and y and see what the answer is coming to. Okay, just for a recheck. I hope this whole process is very clear to you. I know it is already jumbled up here, here and there, but still I'll make a line to make you understand. Okay, it's there. You can rewind the video and check it. It will be quite easy for you to understand. This is another question, the same type. You can see here it is 2 cross 2 matrix. This is a first matrix. Okay, and this is the resultant of the 2 matrix, this and x, which states that it is 2 cross 1. Right? Now, as per again the rule, the column of the first matrix should be equal to the row of the second matrix. Now, which is the column of the first matrix? This is 2. Okay, suppose here it is A cross B, right? So that means A should be equal to 2, right? Because the column of this first matrix should be equal to the row of the second matrix. So A will be equal to 2. Now remains that we know the matrix, the resultant matrix order will be the row of the first matrix cross column of the second matrix. That means 2 equal to B. That means that is 2 into B, not 2 equal to B, 2 into B. So that means here it is, that is B will be equal to 1. Okay, so X order is 2 comma 1. Okay, or you can simply write 2 cross 1. This one will be in the column matrix A, B. Okay, because 2 rows and 1 column. This is 1, 4 multiplied with AB. That is equal to 12, 10. Now see what you are getting. You are going to have, if I can finish doing here, a lot of space is there for calculation. 8A minus 2B, that is plus minus minus. Again, 1 into A, that is A plus 4B. That is equal to 12, 10. So that means 8A minus 2B is equal to 12. A plus 4B equal to 10. Right? So simply do one thing. Take this as equation 1, this as 2. Multiply this with 2. Because here it's 4B, plus is there, here minus is there. Simply we can cut off. So 16A minus 4B is equal to 24. Here we are getting, this is with into 1, A plus 4B equal to 10. So cut it off, we are getting this as 17A equal to 34. So A is equal to 34 by 17. 17, you know A is equal to 2. Now put the value of B here. B we are getting, okay, so 8A minus 12, that is equal to 2B. So A we have got as 2 minus 12 is equal to 2B. 16 minus 12, 2B. 4 equal to 2B. So B is equal to 2 again. So that means A's value is 2, B's value is also 2. Now put the value in this 2 and see whether it is coming to 12 and 10 or not. So A is how much? I said that is 8A. That means 8 into 2, that is 16, minus 16 minus 2 into 2 is 4. You are getting 12 again here. A is 2 plus 4 into 2, that is 8, again 10. Understood? So just for verifying, do that particular calculation, okay, at the last, just to verify whether your result is correct or not. So better try it and hopefully you can finish it up very fast. Anyway, do well, stay well, and yes, see you in the next day with another chapter. Okay, till then stay with us. Thank you and have a good day.